So combination of resistance, basically it's a series combination and parallel combination. But first of all, why we combine resistance? What is need for combination? So basic need of combination is, like if you want more resistance, let's say you have a 2 ohm resistance, 2 ohm, like you have a 3 resistor and each resistance 2 ohm, and you want 6 ohm resistance, obviously you have to combine in the series. Again, if you have a 3 resistor of a 2 ohm each and you want less resistance, then again you need to combine in parallel combination. So that is need of a combination of a resistor. That's why we combine resistor. Okay, so this is the need of a combination. Now in series combination, what we do, look at this diagram. If you see this, if you pay attention on this diagram, this is the series combination. In a series combination, what we do, we take one battery, one resistor R1, second resistor R2, third resistor R3. It's not like every time we are taking 3 resistor, we can take more than 3, we can take less than 3 also. So this voltage V divide into 3 parts. This is V1, this one V2, this one V3. And I current will flow from this one and clockwise direction we are taking. Right. Now this V only divide into 3 parts. This V only divide into 3 parts. So if I say V is equal to V1 plus V2 plus V3, but V is equal to V1 plus V2 is plus V3. Why? Because this V only divide into 3 parts. So we can also write V is equal to IR is equal to IR1 plus IR2 plus IR3. And I can take I common, so in that case R is equal to R1 plus R2 plus R3. This formula is called series combination of a resistor. Means if there are 3 resistor, 4 resistor, 5 resistors, simply you will add, that is called combination, series combination of a resistance. And how we recognize series combination? By the way, in this case, in this diagram, if you see, it look like series combination because R1, R2, R3. But in complex diagram, you won't able to recognize series combination. In that case, only one concept is there, that current should be same. If current is the same in all resistors, that resistors are called series combination. That combination is called series combination of a resistor. If current is same in all resistor, so we say that combination is series combination of a resistor. Right. Now, in series combination, R is equal to R1 plus R2 plus R3. Means whatever number of resistor we'll get, we'll simply add and we will get series combination of a resistor. So let's see parallel of resistors. So this is the parallel combination of resistor, and if you see the diagram, it look like parallel combination of resistor. This is the parallel combination. What is there? This resistor R1, second resistor R2, third one R3, and there is one battery B. Now this voltage V1, this voltage V2, this voltage V3, but they are in the parallel. So V1 is equal to V2 is equal to V3. So in this case, what will be equal? Voltage will be equal. So what I can write, V1 is equal to V2 is equal to V3. In this case, voltage will be equal. So current is I. Let's say current at this point is what? I. So current in this one, it will be I1. Current in this one, it will be I2. This one, I am taking I3. Okay. Now I can say Y is equal to I1 plus I2 plus I3. Obviously, incoming current at this point should be equal to outgoing, because loss of energy will be 0. So we also know V is equal to I into R. So V divided by R is equal to I. Similarly, I can write V divided by R1 is equal to I1. V divided by R2 is equal to I2. And V divided by R3 is equal to I3. This is the Ohm's law. This rule I am using, this is called Ohm's law, obviously we know. Now what we can do here, in place of this I1, I will write this value. Which value? I will write this one, this value in place of I1. In place of I2, I will write this value. In place of I3, I will write this value. So if I write this value, so I'll get V by R is equal to V by R1 plus V by R2 plus V by R3. Now if I take V common from this one, so I'll get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is called parallel combination of a resistor. So one thing, in this one you can simply say it's a parallel combination, it's a fine, but any complex circuit will be there you are not able to recognize it's a parallel combination. So one thing you have to be careful, voltage should be equal, V1 should be equal to V3 is equal to V2. I mean all three voltage should be equal. In that case that combination will be parallel combination, and what we have done is series combination, all current should be equal. In each resistor current will be equal. So finally in conclusion, series combination means in all resistor current should be same, and parallel combination means in all resistor voltage should be same. So we got basically two formula. This is for series parallel combination, and before that we got one formula, R is equal to R1 plus R2 plus R3. This formula is for series combination. So in this one, what do you want to find out? I want to find out net resistance across AB. Across AB, I want to find out net resistance. You can see this circuit. In circuit diagram, this is 3 ohm, 3 ohm, 3 ohm, 3 ohm. I mean there is hexagon and each side will be 3 ohm. And there are 3 diagonal. This diagonal 6 ohm. This one also 6 ohm. This one also 6 ohm. So what I want to find out in this one, actually, I want to find out resistance between A and B. What is net resistance across AB? So for that, I will use series combination or parallel combination formula. So let's start this one. So if you see this 3 ohm and this 3 ohm, they are the series combination. So I remove this 2 and in place of this one, I will write 6. Which formula I am using? I am using simple formula that R is equal to R1 plus R2. So in place of this one, I am writing 6. 3 plus 3, that will become 6. So if I use that one, and I will write 6 over here. So this one will be 6 ohm resistor. Now you can see this 6 ohm resistor, this 6 ohm and this 6 ohm, they are in a parallel combination. So what is parallel combination of 6 and 6? 1 by R is equal to 1 by R1 plus 1 by R2. This is formula. So 1 by R is equal to 1 by 6 plus 1 by 6. And if we solve this one, that will be 2 by 6. R is equal to 6 by 2, and that will be equal to 3. It means combination of this 6 and 6, parallel combination of 6 and 6, that will become 3. So what I'll do, I will just remove this one, and in place of this one, I will write 3. So combination of these two, it will become 3. So in place of this one, what I am writing? 3 ohm resistor, right? Now you can see this 3 ohm and this 3 ohm, again they are in the parallel combination. So this 3 ohm and this 3 ohm, this 3 ohm and this 3 ohm, they are in the series combination. The 3 and 3, they are in the series combination. Again, I remove this 3 and 3 in place of this one. What will write? 6. Series combination 3 plus 3, it will become 6. So this one will become 6. Now this becomes 6. Now this is 6 ohm and this one already 6 ohm. You can see this is 6 ohm and this one also 6 ohm. Now this 6 and this 6, it will become 3 again because of parallel combination. You can see this formula. Okay, so because of parallel combination, it will become 3 again. Now this will become 3. So in place of this one, what will write? I will write 3. So this one will be 3. Again, you can see this 3 ohm and this 3 ohm and this 3 ohm, they are in the series combination. It will become same 6. 3 and 3, it will become 6 series combination, and same logic we will continue. So this 3 and 3, it will become 6. This will become 6. Now you can see this 6 ohm and 6 ohm, again it will become 3, same logic. So in place of this one, I will write 3. I will write 3. And this 3 and 3, this 3 and 3, again it will be in series combination. So this 3 and 3, it will become, this 3 ohm and this 3 ohm, it will become in series combination. So again it will become 6. So I will write 6 over here. So I just remove this one and I will write 6 over here. So I am writing 6 over here. In place of this one, I am writing 6. Now final thing what we are getting, this is 6 ohm and this one is 3 ohm. Now this 3 ohm and this one 6 ohm. So this one will be 6 ohm, this one 3 ohm, and this will be in parallel combination. So 1 by R is equal to 1 by R1 plus 1 by R2. So if I solve this one, so 1 by R is equal to 1 by 6 plus 1 by 3. You can see LCM is equal to 6, and here it will be 1 plus 2. So 1 by R, 1 by R is equal to 3 by 6. It means R is equal to 6 by 3. That will be 2 ohm. So final answer for this one will be 2 ohm. Let's solve some other question. Now this is one circuit. 2-volt battery is here. 2-volt battery connected over here. At this point 2-volt battery. This one is 2 ohm resistance. This one 2 ohm resistance. This one 2 ohm resistance. This one also 2 ohm resistance. What I'm asking for, what will be current in the battery? What is the question? What will be current in battery? Means find out current in the battery. What is current in the battery? What will be current in battery? So you have to find out current in battery basically. So what we need, we have to find out combination of this all resistance. These two resistors are in parallel combination, 2 and 2, and this again parallel combination. So if I take parallel combination of these two, so 1 by R is equal to 1 by R1 plus 1 by R2. This is formula. So 1 by R is equal to 1 by 2 plus 1 by 2. So if we calculate this one, 1 by R is equal to 1. It means R is equal to 1. So combination of these two, 2 and 2, it will become 1. So similarly, combination of another 2 also become 1. Means in place of this one, what I can write, 1 ohm resistor. And in place of this one, 1 ohm resistor, I can write like 1 ohm resistor. And similarly, in place of this one as well, I can write 1 ohm resistor. This is also 1 ohm resistor. Why? Because again parallel combination will be there. So this is 1 ohm and this one is 1 ohm. Now you can see this 1 ohm and 1 ohm. This 1 ohm and this 1 ohm and this 1 ohm. These two are in series combination. So what is net resistance? R is equal to R1 plus R2. So that 1 plus 1, that will become 2 ohm. Okay, so net resistance is equal to 2 ohm, and you know net voltage is equal to 2 volt, and V is equal to IR. This is called Ohm's law. It means I is equal to V divided by R. And what's the net R? Net R is equal to 2, and net voltage also 2. So 2 divided by 2, that will be 1 ampere current. So here current will be 1 ampere.